So the next point in the unit is use of principal component analysis. So in order to get around the problem of multiple collinearity, that means the fact that different components of an index are highly correlated with each other, we can use this particular concept of principal component analysis. This particular concept of principal component analysis combines and modifies the data from interdependent categories so that a new sets of mutually independent categories will be there. Once we take out all the cross correlations from the data, then we can work with new set of variables. For example, in the year 1994, Asian Development Bank and the government of Norway co-financed a study executed by Harvard University's Environmental Systems Program. The aim of this study is to develop a new set of indices to monitor environmental changes among the developing members countries of EDB, at that time Asian Development. Approximately 30% of EDB loans were for environmental and socially sustainable issues, and that particular percentage is nearly amounted to around 2 billion to 3 billion dollar per year. The question was that how to assess the environmental quality of the developing member countries of EDB Bank with such different ecological conditions as PRC, that is People Republic of China, and the Marshall Islands. In order to accomplish this task, this particular study creates a large database which consists of 79 environmental indices in 146 countries which examine, and this particular studies uncover several difficulties. So the list which has been prepared in that database ends up with 33 indices covering only 17 countries. Okay, and that particular indices which is found are highly multicollinear. That is, when measuring one dimension, they're also measured a little bit of another dimension. With that example we have already taken for indicators, considering the case of US fuel measurement of that vehicles. So in this particular technique, what we have done, we have rotated the axis upon which all the indices were measured, and we got 33 indices that were entirely independent of each other. And these 33 indices are expressed as linear functions of original indices. Also, when examining this indices, it is found that first four principal components, that is the first four new indices, covered almost 70% of total variance in the database. Then this is data reduction, which started with 33 indices and boiled them just to 4. These 4 indices were composed of pieces of original 33. So out of that 4, the first principal component has many air pollution indicators in them. In a similar fashion, the second was devoted to deforestation and soil degradation. The third one is related to biodiversity and endangered species, while the fourth dealt with the water quality. So in this way, principal component analysis help us to sort down 33 interdependent indices into 4 mutually independent